welcome, welcome everyone. You can see this is one of the basic mathematics chapters, Trigonometry Fundamentals. I'm going to discuss here, and I would like to start with the right triangle. यहाँ पर जो एंगल है ये 90 डिग्री है या फिर इसको π/2 रेडियन भी बोल सकते हैं. डिग्रीज और रेडियंस, degrees and radians, they are both units of units for angles. Angles are measured in degrees or radian, and the basic relation between degree and radian is pi radian is equal to 180 degree. That means π/2 radian is equal to 90 degrees. So I would be referring either 90 degree or π/2 radian. And there are a few conventions in trigonometry I would like to discuss with you. In a triangle ABC, as you can see at your screen, if we let A, B, C denote the length of the sides BC, CA and AB, usually make this way. The side opposite to the angle A is called is simply denoted by a small a by convention, of course, and the side length like CA in front of the angle B can be denoted by a small b, and C as well. You can see here. I don't see any difference between capital C and a small c here, but this is like what we are talking about. Also the angles A, that is here, angle B and angle C. If I write somewhere angle A, angle B and angle C, it is denoted by the angles. For example, angle A is angle CAB. This is the angle ABC. I would like to write angle ABC as angle B, and angle BCA. And angle C is angle BCA, and like this. So these are few conventions I will be using. Also, you know better from your class 10 syllabus that there are many things like trigonometrical ratios. We usually use 6 trigonometrical ratios, in which 3 are basic or fundamental trigonometrical ratios are called trigonometrical functions. These are sine, tangent and secant. Also there are 3 co-functions. Cosine is usually called cos, cotangent is usually called cot, and cosecant is usually called cosec, or sometimes it is simply written as CSC. So we have 3 fundamental, 3 basic functions and 3 co-functions. Being a co-function means sine can be converted into cos, tan can be converted into cot, and sec can be converted into cosec, and vice versa, like this. And usually you already know that you can find sine of the angle A and usually write it as sine A, and sine A will be perpendicular by hypotenuse, that is A by C. In the similar manner, cos A, you can write cos for angle A will be base by hypotenuse, that will become B upon C, and tan A which is perpendicular by base, can be written as a upon b. So one thing you can use here is the Pythagoras theorem. And in this right angle triangle, we know the Pythagoras theorem tells us the squares of perpendiculars and bases. The sum of a square of perpendicular and bases is equal to the square of hypotenuse, that is a square plus b square equals c square. It directly came from the Pythagoras theorem. You can prove it as well. And so if you wish, you can write here a square upon c square plus b square upon c square equals 1. It's a simple manipulation. And a by c, since a by c is sine a, that means a square upon c square can be written as sine square a. And b by c, you can see it is equal to cos a, so b square by c square can be written as cos square a, and that will give you a result that is important. That is an important result as well as very popular. You can write it for any angle. So in case you want to generalize this relation for any angle theta, you can write sine square theta plus cos square theta equals 1. Though it is originally derived for acute angles, but you can use it for any angle. And if you divide both sides of this equation, sine square a plus cos square a equals 1 by simply by sine square a, you can get something like 1 plus cos square a upon sine square a is cot square a, and then you will get 1 by sine square a, that will become cosec square a, and you will get another result. You can get another result by simply by dividing the equation, this equation, by cos square a, and that will if you divide both sides by simply by cos square a, you can write here tan square a plus 1 equals 1 upon cos square a is sec square a, and sorry, you can also write it as sec square a minus tan square a equal to 1. That is perhaps the popular version of this equation or the formula, you can say. And you can get many things like this. Similarly, if we consider few spatial angles, we are just talking about talking in symbols, and we are talking about angle A, angle B, angle C. But if you consider few spatial angles by simply drawing a right angle triangle like this, and make it हालांकि मैं बना नहीं सकता, but make it an isosceles right angle triangle. 90 degree is here, and if we take 45 degree, this angle will automatically become 45 degree. And if you name the corners simply by A, B, C, or write them in the conventional manner, this side as A and this side as B and this side as C, then you can see here these two sides, AC and BC, will be equal by symmetry, and that means you can also write A is equal to B, and it happens in isosceles triangles. And if you use here the Pythagoras theorem alone, you will get something c square equals a square plus b square. And since a and b are equal, you can write c square equals 2a square, and then you will get a upon c square equals 2. And if you take the square roots of both sides, you will get a upon c equals a upon c is 1 by 2. Sorry, a square upon c square is 1 by 2, not 2 simply. A square by c square cannot be 2. So if you take the square roots, you will get a by c equals 1 upon root 2 only, because a and c are both positive. So you will get a positive value of mod 1 by root 2, and because under root x square is mod x, always mod x, not x. So we have to take the positive value of 1 upon root 2, and it comes out. And you can see here, what is this a by c? A by c, if we take this 45 degree, a by c is base by hypotenuse, that is cos 45 degree. And if you take this 45 degree, a is perpendicular and c is hypotenuse, so you can write it sine 45 degree as well. That means sine 45 degree and cos 45 degree both have the same value, and that is equal to 1 upon root 2. So that means tan 45 degree is going to be 1, and cot 45 will also become 1. And so, but you can do one more thing. Let's make one more right angle triangle like this, and name their corners as A, B and C here, and just take this angle equals 60 degree, and this angle will be automatically 30 degree. And if we reflect A across the side BC, just we are trying to make a mirror image of A across the line BC, and we do it by creating a new point, new corner, and I name it D. That means, and C is here, that means C is here, and that means few things like AC will be equal to CD, and that will be equal to AD upon 2, and this angle will be definitely 60 degree. This is right angle, that means this angle is 60 degree, 30 degree. That means we started from a right angle triangle, and we have got an equilateral triangle. We have an equilateral triangle right now. All three sides are equal. That means AB is equal to BD is equal to AD. So I can write AC equals AB upon 2 as well, because AB and AD are equal. And this triangle is an equilateral triangle, and there is a right angle triangle we have. You can see here, both within the triangle ABD we have two right angle triangles, and we can do one thing. We can write Pythagoras theorem here, like AB square, and that will be equal to AC square plus BC square, and we can manipulate it a bit and write BC square equals AB square minus AC square. And so this AC is AB by 2. That means you can also write BC square equals AB square minus AC equals AB by 2. That means AB square by 4. And that means you got BC square equals 3 by 4 AB square. And what you get here is BC upon AB is simply root 3 by 2. We just did the same thing, applied the square root both sides, and we got it BC upon AB equals root 3 by 2. And BC upon AB can be written as simply as cos 30 degree, or if you take this angle, this BC upon AB you can write sine 60 degree. That means cos 30 degree and sine 30 degree have same values and equal to root 3 by 2. And in the same manner, if you want to know sine 30 degree, then the perpendicular is AC. That means that is AB by 2, and hypotenuse is AB. So you will get sine 30 degree equals 1 by 2, and this is also equal to, if you take this angle for this angle under consideration, this AC is the base and AB is the hypotenuse. So you can write it as cos 30 degree as well, cos 60 degree as well, sorry. So that means sine 30 degree equal to cos 60 degree, and cos 30 degree is equal to sine 60 degree. They are different pair of values, but sine 30 degree and cos 60 degree are same and equal to 1 by 2, and cos 30 degree and sine 60 degree will have the same value, that will be equal to root 3 upon 2. You will soon see that you will be able to find 0 degree, sine 0 degree, that means cos sine 0 degree, cos 0 degree, sine 90 and cos 90 as well. But how can you do this? Let me give you an exercise. Let me provide you an exercise to practice you something. Suppose I'm giving you a triangle. Let's name its corner simply by ABC, and draw a perpendicular from C to the side length AB, and name this perpendicular as CD. And if you provide AB equals X, that is given, I am providing you, and this angle simply as theta, then express all the lengths of the segment in terms of X and theta. That means I am asking you to express AD in terms of X and theta, and then after doing this you can express dB in terms of X and theta, AC as well, and CB also in terms of X and theta, and your work will be completed. And now that you know many things, you can do one thing. You can verify yourself that the trigonometric functions do not satisfy the additive distributive law, which is can be written as sine alpha plus beta equal to sine alpha plus sine beta, and this doesn't happen. That means these trigonometric functions do not satisfy the additive distributive law. You cannot also write cos alpha plus beta equal to simply as cos alpha plus cos beta. This is also not possible because they are not true. But how? What will be the actual value of sine alpha plus beta and cos alpha plus beta? You have to know this. And to get the values of sine alpha plus beta and cos alpha plus beta, I'm suggesting you to do some geometry, like you can draw a rectangle first. Name its corners simply by A, B, C and D, and then draw a right angle triangle inside this rectangle. To draw the right angle triangle, I choose the point D and draw a line to meet AB at point E. This corner, this is E, and then I draw a perpendicular to meet the line BC, that side BC. Here is the perpendicular, and name it the point F, and then join points D and F. And also take few things. The first and foremost thing is you must take df equals 1 units. Just 1 unit. Just assume that df is equals 1 unit. There is no harm in it because it makes our calculation a bit shorter. And take this angle as beta and this angle as alpha, and you have many triangles, many right angle triangles. You can see here this is now 90 degree. That means this angle is 90 minus alpha, 90 degree minus alpha, 90 minus alpha, and this angle is 90 degrees. So altogether these two angles form 180 minus alpha, and this whole angle is going to be 180 degree. That means this angle will become alpha, simply alpha, and this is 90 degrees, so this angle is going to be 90 minus alpha, this angle as well, and this angle is beta and this angle is 90 degrees, so it will become 90 degree minus beta. That means this angle will be alpha plus beta. You can verify them, and you just did everything as expected. This angle is again 90 degree because we know this is a rectangle. So, and what do you need to do? You have I guess you have many triangles, 1 2 3 and 4 triangles, 4 right angle triangles, 4 smaller right angle triangles ascribed inside a rectangle, and you already taken df equals 1 unit. So you go and try one triangle after another. So I am going to take first triangle as triangle DEF. You can see here DEF, the middle one, and find few things like in this triangle, considering this triangle DEF, you can find cos beta, and cos beta is here, you can see. So cos beta will be base, that is DE upon hypotenuse, D upon TF, and DF is 1 units. That means you have DE equals cos beta. You got your first result. Congratulations. Then you try to find sine beta in here, and sine beta is, that means perpendicular, that is EF divided by the hypotenuse DF, that is 1 unit. So you got your second result, that is EF is equal to simply sine beta. So you got 2 results. Now consider this triangle, the triangle ADE, this left triangle, and considering triangle ADE, you have nothing to do. You can see there is an angle alpha, so just try to find cos alpha and sin alpha. Let's first find the value of cos alpha, and cos alpha will be base, that is AD upon hypotenuse is DE this time, AD upon DE, and you can see here that AD can be written as DE cos alpha, and that DE you already have, this is equal to cos beta. That means AD equals cos alpha cos beta. So congratulations again, you got one more value, that is equal to AD. Now try to find sin alpha, and sin alpha in this triangle, in this left triangle, will be perpendicular by hypotenuse, that is will be AE upon DE, and don't forget you have D equals cos beta. That means you got the value AE equals DE, that means cos beta and sin alpha. So I will be writing it as sin alpha cos beta, and that you have another result, sin alpha A equals sin alpha cos beta. Now consider another angle, that is BEF. So we are now considering another triangle BEF, and in this triangle what can we do? There is an angle alpha here, so we can find cos alpha and sin alpha. So let's find cos alpha first, and cos alpha is nothing but cos alpha is base, that is BE upon EF. EF is the hypotenuse here, B upon EF. EF, you know from here, is sin beta. That means you got BE equals cos alpha sin beta. Cos alpha sin beta. So you got another value, BE equals cos alpha sin beta. Now try to find sin alpha in here. And sin alpha in this triangle is perpendicular, that is BF upon hypotenuse, that is EF. So you will write BF by EF as a sin alpha, and EF is sin beta. That means BF will become sin alpha sin beta. You did many things right here. And now you have to consider one more triangle, right angle triangle again, that is triangle FCD. Triangle FCD. And we have one angle, that is alpha plus beta. So try to find sin alpha plus beta first. Oh, we break the rules. We should have tried first the cos alpha plus beta. Okay, sin alpha plus beta is also fine. So sin alpha plus beta is perpendicular by hypotenuse, that is DC upon DF. That is DC upon DF. And we already have DF somewhere. And that means DC or DF. DC can be also written as CD. I find it better. So CD can be DF sin alpha plus beta. And DF is equal to 1. You can see here, DF is unity. That means this CD is only sin alpha plus beta. DF is only sin alpha plus beta. And you can find cos alpha plus beta as well. And cos alpha plus beta will be base, that is FC, divided by hypotenuse DF, that is unity. That means FC will be equal to simply cos alpha plus beta. So you just did it, everything you wanted to do. Now we can do one more thing, but the whiteboard before me is full, but still I can make something. You can see here our result as here, if you consider this thing AD, this AD is equal to BC, and we have the value of AD. So just think about it, that AD will be equal to BC, right? And AD is cos alpha cos beta. From here, cos alpha cos beta. and BC is nothing but BF. If you see the picture, BF plus FC, and we have values of BF and FC both. BF is sine alpha sine beta, so I'm writing again that we have cos alpha cos beta equals BF, that is sine alpha sine beta plus FC, that is cos alpha plus beta. FC is here, and that means we have cos alpha plus beta equals cos alpha cos beta minus sine alpha sine beta, and this is one particular and very important result. But the pick is lost, and I have to get sine alpha plus beta as well. So I will suggest you that you look at this picture again and look at this particular CD. And CD is equals AB. Am I right? CD equals AB. And AB is AE plus EB. AE plus EB. So I'm going to write here CD equals AB and AB equals AE plus EB. And CD, we have somewhere CD, and you can see here CD is equal to sine alpha plus beta. So I'm going to write CD equals sine alpha plus beta. We don't need AB because AB is already written in terms of AE and AB. So we have to find out what is the value of AE. You can see here, this is sine alpha cos beta. Sine alpha cos beta plus EB. We have somewhere EB or BE here, and it is cos alpha sine beta. Cos alpha sine beta. Can you see it here properly? BE, that means EB is cos alpha sine beta. So we got another result, that is sine alpha plus beta equal to sine alpha cos beta plus cos alpha sine beta. They are called sum rules or formula for sum of angles, and these are popular formulas. I think we are thinking within the box, and we have got addition formula, what is called they are called perhaps the addition formulas in trigonometry, and we got it for sine and cosine, and if you want you can get it for tan as well, because you can always write tan alpha plus beta is equal to sine alpha plus beta divided by cos alpha plus beta, and just put the results we already obtained. Sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta divided by cos alpha plus beta. You can write from here that it is cos alpha cos beta minus sine alpha sine beta. And if the result looks bigger for you, or the result is not written in terms of tangents, they are written in terms of sines and cosines, then you can also manipulate it. Just divide the numerator and denominator by cos alpha cos beta, and if you divide this thing sine alpha cos beta by cos alpha cos beta, you will get simply tan alpha, because cos betas are getting cancelled. And again do same thing here, cos alpha gets cancelled out and you will get simply as tan beta. And in the denominator you have 1 minus sine alpha by cos alpha is tan alpha, and sine beta is cos beta is tan beta. So you can get tan alpha plus beta as well. And we have just proven the addition formulas for the sines, cosines, and tangent functions for angles in a bit restricted interval, but we can use it no matter what. And we can develop an addition formula for cotangent function as well, but I leave it as an exercise to you. And you can do one more thing. You can set alpha equals beta equals say theta, and then in the addition formulas we will obtain the double angle formulas, that is sin alpha plus beta is now become sin 2 theta. And if you see that you have to replace both alpha and beta by theta, you can see very easily that you have got sin 2 theta equals 2 sin theta multiplied by cos theta. This is one more result. And similarly you can obtain cos 2 theta as well, cos 2 theta. And you need to see this result. You just have to replace alpha and beta by theta and you will get your result. That will be cos square theta minus sin square theta. And remember, you have one more result, that is sin square theta plus cos square theta equals 1. And you can manipulate this result in many ways. I don't know what form of cos 2 theta you needed in a particular situation, but I'm just suggesting that you can use these two things together and get your forms you need to get in a particular situation to solve the particular situation. In the similar manner, you can get tan 2 theta, and that will become 2 tan theta divided by 1 minus tan square theta. You can see from here. So in addition to this formula, you can find the triple angle formulas as well. But I left it as an exercise for you. And we need to do some more things. Like I'm going to invite a unit circle for having some manipulations, because well, you can find sin 90 and cos 90 now by putting theta equals 45 degree, and you can get your sin 90 degree, that is sin 90 degree. You should find 2 sin 245 degree, and you will get 2 sin 45 multiplied by cos 45. They will have both will have the same value, and you will get that sin 90 degree equal to 1, and you can get sin cos 90 degree as well. That will come out at 0, but you cannot find the sin 0 and cos 0, but you have to find them. So I'm going to invite a unit circle in our discussion to make things even. And this is a circle at your screen. Here is its center. Just draw the coordinate axis, usual x and y axis, and divide this circle into four quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And I guess you have prior information of writing coordinates in various quadrants, and you must know that in the first quadrant any point will have both x and y positive. For a point in the second quadrant, x will be negative, y will be positive. In the third quadrant, both coordinates will be negative. and in the fourth quadrant x will be positive and y will be negative. So just utilize the first quadrant and take here a point A. This is a unit circle, that means its radius is unity. This is a unit circle. That means its radius is equal to 1. That means OA will be equal to 1. And let this angle being theta. Then the coordinates of point A you can write here is its x coordinate will be simply cos theta and y coordinate will be sin theta. Just cos theta and sin theta. And now if you take a point B here in the second quadrant and make this angle alpha and make this angle beta, then from the point of view of beta, this point V will have coordinates like its x coordinate will be obviously negative, but this length will be simply cos beta. So its x coordinate will be minus cos beta and y coordinate will be sin beta only. And if you take this angle alpha, its x coordinate is going to be sin alpha and don't forget to put a minus sign here because you are dealing with a point in the second quadrant, and its y coordinate will be cos alpha simply. And now consider one thing. This angle alpha, you can say that this angle is 90 degree and then you moved another angle alpha. So if you take drawing your angles from starting from this arrow only, the positive x-axis, that is OX in the picture, you should have written the coordinates of point B as like this, as cos 90 plus theta and sin 90 plus theta, sin 90 plus alpha, in fact, not theta, cos 90 plus alpha and sin 90 plus alpha. You should have written like this. And that means if you compare these two results in terms of alpha, you could have agreed at this moment that cos 90 plus alpha will be minus sin alpha, because these two are the coordinates of same point, say they must be same, and sin 90 plus alpha must have been cos alpha. Or you can do one more thing. I can do it for you. If you consider this angle beta and started finding your angles from here, you can see you go to here, and since the whole angle is you can see the semicircle here, so the whole angle is 180 degree, and then you have to find this angle. You have to you went anti-clockwise, counterclockwise, and reach to this point by making 180 degree, and then you have to return to this point. So this point, in this case, you have to move backwards and rotate in clockwise sense by an angle beta. So the whole angle becomes 180 minus beta. You cannot write it 180 plus beta. You must have written it by any means as cos 180 minus beta. Though I can introduce you to a convention that when we rotate in anti-clockwise sense, we consider angles as positive, and when we rotate in clockwise sense, we consider angles negative. But why, you can understand right now that if you start from here and reach here, you should have written the whole angle in terms of beta as 180 minus beta. So you could have written then the coordinates of this point B in terms of cos 180 minus beta simply as cos 180 minus beta and sine 180 minus beta. Yeah. And if you compare these results with this beta thing, you could have understood that cos 180 minus beta must be minus cos beta, and sine 180 minus beta, it must be equal to sine beta. You can do this for a point in this quadrant, and you can do this again for a point in the fourth quadrant. Suppose fourth quadrant is important. Suppose this angle is say gamma. If this angle is gamma, then by convention its x coordinate must have its x coordinate must have been positive and y coordinate negative, and this length is 1, so this length is cos gamma, so its coordinates should be written as cos gamma, and this length will be sine gamma, so its coordinate must have been written as minus sine gamma. And now start from the positive OX axis and move to this point. You move this time not in anti-clockwise sense but in clockwise sense. So you can also write its coordinate as cos minus gamma and sine minus gamma. Then comparing these two results, you can call that cos minus gamma is basically cos gamma and sine minus gamma is minus sine gamma. And these two results are important because you can easily find the others. And then since you have the results like sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta, and if you want to find sine alpha minus beta, you can write it as sine alpha plus minus beta, sine alpha plus minus beta. And in this formula, sine alpha minus beta, that is sine alpha plus minus beta, you can find it simply by replacing beta by minus beta. So you have cos alpha cos minus beta plus cos alpha sine minus beta. And just one more line of manipulation and you can get your result. Cos minus beta is of course cos beta, so you should have written it sine alpha cos beta simply, and then sine minus beta is minus sine beta, so put that the minus sign here only, and you can write cos alpha sine beta like this, and you got your sine alpha minus beta. So you can get your sine 0 degree, and if you manipulate the cosine result, you will also get cos alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. And you can also find the cos 0, and so this calculation is done. This calculation is completed, but sometimes you need a different formula as well. When you study, you will be needing besides this addition and subtraction formulas, you will need something else like that is called sum to product formula. So I am going to provide you this formula as well, as at least you can try by yourself. And this is sum to product formula. And what do we mean? That means you can get something like sine alpha plus sine beta. If you need to find sine alpha plus sine beta, what can you do? You can write sine alpha simply by sine alpha plus beta by 2 plus alpha minus beta by 2. And you can see this is sine alpha, yet this is sine alpha, this nothing changed. And in the similar manner, you can write sine beta by sine alpha plus beta by 2 minus alpha minus beta by 2. Why I am doing this? It is clear. You can write like this. And then you can use the formulas for sine A plus B, and you can write here sine alpha plus beta by 2. This is routine work. Cos alpha minus beta by 2 plus cos alpha plus beta by 2 and sine alpha minus beta by 2. And the second term, again sine alpha plus beta by 2 minus alpha minus beta by 2. You can write here like this: sine alpha plus beta by 2 cos alpha minus beta by 2 minus cos alpha plus beta by 2 and sine alpha minus beta by 2. And see what you got. These things will cancel out, and you will get simply 2 sine alpha plus beta by 2 and cos alpha minus beta by 2. And you can manipulate other things like this simply by using this approach. And this is called sum to product formula. You can also find sine alpha minus sine beta, and that will be called difference to product formula. But I don't have left that much energy to keep to formulate it myself. So you can do this, I hope. And thank you very much for watching.